Hi, friends. I'm so excited to welcome all of you to the first science night of the fall season offered by the National MagLab in partnership with the Leon County Public Library. I'm Miss Stephanie. I'm a librarian at the main library downtown. Super excited. I have with me some scientists from the National MagLab in Tallahassee, and you're going to be learning about electricity tonight. I know you're just as excited as I am. And that's really all I have to say on my part. I'm super excited to have the MagLab scientists with us tonight. I'm going to hand it off to Yulia, and she's going to introduce our other presenters tonight.
All right, thank you, Stephanie. Thank you for working with us. We're excited for another season of Science Night with the library, and hope to move back to in-person science nights at the library, hopefully in the new year. So thanks for having us. As Stephanie said, we're from the MagLab out on Innovation Park in Tallahassee. We do lots of science and engineering and technology, all centered around magnets, and electricity is a big part of that, and that's the topic of tonight. And with us, we have Ms. Sujana, who's an electrical engineer. So she is going to guide us through tonight. And we have also Mr. Carlos with us, who is our science outreach magician, awesome outreach educator.
Hey everyone, I'm just a big nerd and geek, and I'm happy to be here.
And he will also help us facilitate tonight, and he will work the chat. So if you guys want to talk to us, have questions for Sujana, have questions for us, type them in the chat box, and Mr. Carlos will channel them straight into the program. All right, with that, I would like to pass on to Ms. Sujana. Welcome everybody and enjoy.
Hi guys, welcome. I'm Sujana. I'm an engineer at MagLab. I'm going to talk about electricity. So our topic, So today's topic is let's get cracking with electricity. I guess we are going to talk about different kinds of electricity and how is it useful to us. And if you guys have any questions or anything after this program, you guys can email us at the sciencenight@magnet.fsu.edu. So before we start, for our hands-on experiment, if you guys have these things in hand, that would be great. If not, that's okay too. We have other stuff going on. So basic things that you might need when we are doing the hands-on experiments down the lane. So have them ready. If you have them, it's fine. If you don't, that's fine too. So before we get going on our topic, we wanted to know a few things from you guys. Is the chat working for all of you? And can you actually hear and see us? And how old are you? And where are you joining us from? We would like to know. And we want to see who is going to answer it the quickest. So I see one answer. Hopefully people are answering it. So we just want to know to see what kind of group we have today. So I see an increase in the participation. That's good. So if everybody could let us know, that would be great.
All right, Sujana, so far we've got 15 answers so far, so a few more, and then we'll have just about everyone.
Yeah, I'm just waiting for that 100.
All right, I'm ready for the number one. All right, I think we've been at 17 for a while, so I think we're good to go.
Okay. So let's see what you guys answered. So most of you are 4 or 5, 6, 7. Okay, 41% of you are 10 or 11. That's good. And 29 is 8 or 9. And 24% of you are 6 or 7. So it's a good number. So we have a different age groups. That is always fun. And where are you from? So all of you are from Tallahassee. So that's good. Okay. So I'm just going to close the poll and move on to the next slide. So can anyone tell me what electricity is and where have you seen it used and where do you think it comes from? Let us know in the chat. What do you think? And have you ever walked on a carpet and suddenly touched a doorknob and ever got like that shock or being zapped? If so, do let us know. I guess we are going to talk why that's happening today. So I'm going to give a few seconds if someone wants to answer. If not, I'm going to go ahead.
Question has been asked and
Okay.
things are starting to come in now. So let's see. First things first, somebody asked you to repeat what materials they need. Apparently someone joined us.
Okay, yeah, that's fine. So let's see. So here is the slide for the materials, and you need either a balloon or a plastic rod like this, and a plastic bag and a towel if you can. If you guys don't have it, that's fine too. If you guys have just a balloon, that's perfect too. And if you guys don't have anything, that's fine too. I'm gonna show what's gonna happen. So
all right, now as for our questions, talking about electricity, they said it can shock you. It's a flow of energy. Electricity is a type of energy used almost everywhere. It comes from rubbing and static. I'm using electricity right now. Electricity in our homes.
Yeah, that's a very good answer. So I'm gonna go ahead and talk about static electricity. But before I do that, I just wanted to talk about the nature of matter, that the objects that you see around you are all made up of atoms, these small tiny atoms, and these atoms usually consist of what we call are the protons, neutrons, and the electrons, where the protons are usually the positively charged particles and the neutrons are neutral. That means they have a charge of 0, and electrons are the negatively charged particles. So we know that in an atom, usually the amount of negative charge is equal to the amount of positive charge, meaning that electrons are equal to the protons. So when everything is equal, it's usually balanced, right? So in nature, whatever objects you are seeing are mostly electrically neutral because all the charges are there, it's balanced. So, but then again, you know that here, like charges, like if you take protons, they don't like each other, so they repel each other or they move away from each other. While if you look at it, a proton or an electron, they are opposite and they like each other, so they come towards each other. So from that, you can say that like charges, like protons or electrons, repel each other, while opposite charges like a proton and electron can come together. So I'm just going to say it again. Like charges repel, unlike charges attract, or the opposite charges attract each other. So for an example, when two protons and two electrons come closer, they push each other apart, while a proton and an electron attract each other because they have different charges. One is positive and one is negative, so that's why they attract each other. So it's again that time where we are gonna ask you a few questions. So let us know what you guys think. So do like charges attract or repel each other? So most objects are electrically what? Does neutron has any charge? So let us know what you guys think. Even if it's wrong, that's fine. We are here for learning. So just let us know what you think.
Somebody made a very interesting observation when you were talking about the like charges repelling and attracting, and somebody said it's just like the poles of a magnet.
Exactly. Yeah. That's a good example. Yeah.
Somebody else also said that in their house that they have not been zapped, so that's good.
Okay, that's good. So I see most of you guys answering.
We've got 12 so far, and we got 17 last time, so we could wait for a few. Oh, there's 13, 14, I told you. A few more and we'll have 17, and I think that should be everyone.
Okay, so I see most of you answered the first one correct. Like charges repel each other because they are both positive, they don't like each other, so they don't want to come close, so they move away from each other. So the answer is they repel each other. Second thing is most objects are electrically neutral because they are balanced, they are neutral, so they are not positively charged, they are not negatively charged, they are neutral. And yes, neutrons have no charge, That was 50-50. But yes, neutrons have no charge. They are neutral. So hence the name neutrons. So I think we are good with the quiz. 22 out of 25. That's not bad. So I see a good participation. So I guess we could go to the next slide. So I still see. Okay, so we were talking about how like charges repel and opposite charges attract and whatnot. So we want to know why we are getting zapped every time we walk on a carpet and touch a doorknob. So usually it is caused when two different materials rub on each other, meaning that if there are two different objects, on one object, the electrons, some of the atoms, the electrons can be easily be pulled. So electrons can be pulled from one material into another material. That means if you look at the screen, you can actually see the transfer of electrons from one atom of one material to another atom of another material. So what that means is one material will get those excessive electrons and becomes negatively charged, while the other material loses the electrons and becomes positively charged. So what we can say with static electricity is that it is the imbalance of negative charges and the positive charges. Hence, we get zapped every time we walk across the carpet and touch a doorknob. So now that we saw what static electricity is, let's see if we could do hands-on experiments to understand it a bit better. So this is what we need. So if you guys don't have it, that's fine. We are going to show you what to do. So today what we are trying to do is more like a levitation charm, maybe to see how a balloon or a plastic rod will ripple away from the plastic band. So it's not magic. It's with the help of static electricity. So let's get going. So for this, I'm going to use a balloon plastic band. So I'm just going to stop the shares just so that you could see me. So this is the balloon and I'm using a towel, and I took a piece of a plastic from a plastic bag. So what I'm going to do is I'm going to rub this balloon. You guys all can rub your plastic rod against the towel or a piece of cloth for about 40 seconds or so. The harder you rub, the more static you could actually see. So I'm not sure if you guys can see it, but I'm trying to rub the balloon.
Sujana, while they're doing that, I'm also going to tell them that the fluffier something is, the better it's going to work. So if you have a fluffy blanket, definitely use that.
Yep.
And for some of you, your hair will work wonders too. So your hair is a good thing you can try as well. I also jumped in to tell you that one of our students has told us that sometimes at school, they do what's called a shock train. And get this, one person goes down the slide and then shocks everybody that's at the bottom of the slide.
Yeah.
That is awesome. And another secret I know about this too is that shock train
so you can
will work better in the winter.
See that it's actually repelling. Sure, you can't properly see with the background and stuff, but you can actually see that the balloon is going away from the plastic band. That's because I'm gonna explain why. Let us know if you guys were able to do it. If not, we have other videos. So this is what you guys have to do. So you need to rub as much as you can because of friction. So we need that friction. So let us know if you guys were able to do it. Even if it levitates a small amount, that's fine.
I've got at least one person who it worked for, and a few more have told me that they're trying right now.
Yeah, take your time. So yeah, so the more you rub, the more it's gonna levitate. So you could use a balloon, and we also have like a plastic rod here. So you could use that, or try guessing other items that you could use to do this, and let us know in the chat what other items you can do this with. So I'm just gonna go ahead and explain how this works. So we know that so we are rubbing the balloon and the plastic rod as well as the plastic bag onto the towel. That means that we are trying to transfer the negative charges from the towel to the balloon as well as the plastic band or the plastic bag. So what happens is, since both are negatively charged, they are going to ripple away from each other. So let us know what other objects you can try to levitate the plastic bag, and send us a picture of your experiment if you're comfortable with to this email. So I'm hoping more people are doing it and they got it.
Oh yeah, we've got a lot of them that have success. Let me see. I've got 1,
Okay.
2, 3, 4, 5, 6 that worked for.
Okay. Yes, that's great.
7, 8 now. One told me that it hasn't worked, but they're trying again.
Oh, no. Maybe try with a different material. Sometimes some materials just don't work. So.
And I'm going to suggest something, since you're going to ask for pictures for them to send at home. I remember somebody told me once that running water has a slight polarity to it. So
yes,
if you have water coming down the sink and you bring your balloon close to that.
Yeah. So are we good with this, or are we going to give it a few minutes for them to?
So this is a good chance for me to tell them something important, because I've got 2 of them who have told me that it has not worked and they put sad faces. And don't do that. Don't be sad, because Sujana or Yulia or anyone at the MagLab will tell you that our experiments don't always work the first time.
Nope, it's not going to work the first time.
We have a lot of failing, a lot of learning, a lot of trying again. So
yeah, that's a very good point. It's not going to work the first time. I think it's important that we try, and you guys are doing that, and that's the best thing that we can do. And keep trying, try changing one material out of the 3. Maybe the towel or the cloth is not good enough for it to transfer the electrons. So yeah, but keep trying. I think you guys will get there. It's important that we try always. So yeah, don't feel sad. So I'm going to go ahead and do the next one. So this, since we haven't told you guys to have a balloon with you, it's fine. I'm going to show it. If you guys have a balloon, try it along with me. If not, see what I'm going to do. So for this, I'm just going to use an inflated balloon. So what I'm going to do is, I'm going to stop the share so that you guys can see. So this is my hair and this is the balloon. So I'm going to rub the hair on here. So, and then if you actually see, can you guys see my hair is attracting the balloon? Do you see that? So I'm going to do it once more. So I'm using the balloon and my hair, and I'm rubbing the balloon on my hair. And then I'm going to bring the balloon to my hair. And if you can actually see, it's the hair is attracting the balloon is attracting my hair. So we are going to see why.
Yeah, they can see it.
Okay, they can see it. Yes. Okay, that's good. Okay, so let me share my screen again. Okay, so can anyone tell me why that's happening? Why is my hair being attracted by the balloon? Let us know in the comments. Why do you guys think the hair is being attracted by the balloon? So this is what I did essentially. When I rubbed my balloon with my hair, it actually picks up the electrons. So it is leaving. So the balloon becomes negatively charged and my hair becomes positively charged. So we know that opposite charges attract. So when I bring the balloon closer to my hair, it gets attracted to my hair. So that's why the hair is standing up. You guys should do it at home and send us pics again if you're only comfortable with it. But this is something cool that you could show your friends also. It's something cool and you know why it's happening and why is the balloon attracting your hair. So does anyone have a balloon? Is someone trying or? Okay, so I'm gonna go ahead and does anyone have a balloon, Carlos? Okay.
I have 2 people have told me that they've done it 3.
Okay.
So they've got some success at home, and they
Okay.
asked the question, and I think you just answered that, but they asked at the same time, why is their hair attracted by the balloon?
Yeah, so I guess as I said, the balloon becomes negatively charged when you rub the balloon against your hair, and the hair becomes positively charged. So we know that opposite charges attract each other. So the negatively charged balloon is attracted to the positively charged hair. So that's why the hair is being pulled towards the balloon, because the negative charged balloon is attracting the hair. So hope I answered that question. If not, you guys can read it. It's right on the screen. Did that answer the question? Okay.
That was a good answer. And they also said that it works with a plastic bag too.
Yeah, it works. Yeah, that's a good substitute. That's very good, guys. So I'm going to go ahead with the next slide. So we have one more experiment. This will be in the form of a video. So we are going to see, I'm going to go ahead and play the video. So this is another example of static electricity. So to conclude this topic, I'm going to say static electricity is nothing but the electric charge present on the surface of an object. It is mainly because of the imbalance between the positive charges and the negative charges, as you have seen with the help of balloon and a hair and a plastic bag. So yeah, that's about static electricity. So we are going to move on from here. So now we are going to talk about, now that we have seen static electricity, I'm going to talk about a current electricity, or the general electricity that you see around you. Can anyone tell me what the usual current electricity is? Does anyone know? Let us know in the chat.
That is a really good question. So what you're asking is, what is the current, what is current electricity?
Yeah, like usually we say electricity, we have our laptops running and we have everything going on in the household. There's a lot of appliances which work with electricity. So the question is, what is electricity essentially in a small form? If anyone could answer, that's great. If not, that's good too. You're going to learn it here.
So the answer that I've seen a couple times is they are asking, or I'm sorry, they are saying that it's electricity moving through a circuit. Yeah.
No, that's good. Circuit is like a closed path, and the electrons needs to flow. So I would say electricity is nothing but the movement of electrons around a circuit. So okay, so can anyone tell me what an electric circuit is? Now that you guys said what an electricity is, now I want to know what an electric circuit is. So I would say an electric circuit is nothing but it allows a path for the negatively charged or the excessive electrons to flow from the negative pole to the positive pole. It provides that path for it to travel. So that essentially is a circuit. It's like a closed path for the electrons to flow from. As you can see, it says it provides a complete path for the electricity to pass between the two terminals of a battery. So I think some of you guys answered it. It's a continuous and a closed path of an electric current. It's called an electric circuit.
Yeah, we had a couple of answers type in. Somebody said that it's an electric current. Somebody else says that it's something that attracts electricity. I always like to say, because I grew up watching race cars and going to races, that this is the course for the electrons to run through.
Yeah, exactly. Yeah, it's just a path for the electrons to flow through. So for any simple electric circuits, we need three basic parts. One of them is an energy source, and the other is wire, or the part that we are talking about. We need a wire or a conductor so that it could travel so that the electrons could travel. And we also need what's called a load. Load is nothing but, so from the energy which we are using a battery. So the battery usually uses a chemical reaction for it to convert into electrical energy, and we want that electrical energy to be shown to the outside world. That's why we are using a bulb as a load, because the electrical energy is converted into light or heat. So as you can see here, the battery provides the energy which moves the electrons through the circuit. So this is the battery, and this helps the flow of electrons all the way and comes back to the source. So I'm gonna show you a video demonstration of this simple circuit where we have a battery holder, a battery, and we have these wires with alligator clips, as well as a lamp and a lamp holder. So this is what essentially is happening. We have a source or an energy, which is a battery, and the battery converts the chemical energy into electrical energy, and the electrical energy is passed with the help of conductors, which are here in this case, those are wires. And we are going to help or see if the light will glow or not with using this. So, okay. Ta-da! You see that the light glow. So if you see, this is the battery, and this is the battery holder, and these are the alligator clips, and this is the lamp, and this is the lamp holder. So what we are doing is we are connecting the one end of the battery to the one end of the lamp, and the other end of the battery to the other end of the lamp. So what we are doing is we are essentially closing the path or creating a closed loop for the electrons to move from the battery's one terminal through the lamp, and the electrons go back to the battery. So essentially what we are creating is a circle of flow of electrons. So if you guys have any questions, let us know in the comments. So, and
you know, Sujana, the biggest mistake I see, can you go back? The biggest mistake I always see when kids do this is that they'll put the battery in the battery holder. They'll take the alligator clip, connect that to the battery. They'll go all the way to the end and connect that to the light bulb. And then that's when they'll stop, because they think that the battery is going to send electricity to the light bulb and that's the end of it, but it's not.
They need to continue and put it back to the battery so that they close the loop or the circle. So it's always a circle. For the electrons to flow, it always needs to be in a circle. So
and that's a great thing, because if you remember that a circuit sounds like circle, because that's what it is. And I'll tell you another secret that I learned. A teacher friend told me this, that when you go to a circus, you're also thinking of that, because in the middle of the circus, they have rings. So circus, circuit, circle, all based off of the same idea. It's all round connecting things.
Now that we're talking about circles and rings and loops, so can anyone tell me what an open circuit is, or what this is, or what this is acting as on this picture here? So does anyone know what an open circuit is? So usually an open circuit is nothing but, if you want to, as we were just talking, you need the loop to be closed for the current to be passed. Do you have any answers? Okay.
Yes, I do. And they're saying that a open circuit is an unconnected circuit. So we got some smart kids with us today.
So that's it. That's exactly what an open circuit is. It's nothing but an incomplete path. There's an incomplete path between the source and the load, or the lamp in this case. So that's what an open circuit is. For us over here, we are using a switch. Switch is nothing but a simple device that can either make the circuit or break the circuit. So it can be, if it's closed, there is a path. If it's open, it's not going to touch each other. So there's a break in the circuit. So that's what an open circuit is, that there is an incomplete path between the components. So now that we know what an open circuit is, let's see what a closed circuit is. So can anyone tell me what a closed circuit is?
All right, everyone, the question has been asked. We talked about the open circuit. Now, what is a closed circuit? Type it into the box and let's see what they say. First of all, they say yay, because I told them that they're giving me great answers. So yes,
Yeah,
absolutely
they are.
yay.
Yeah, absolutely. Yeah.
But the question of the moment is, what is a closed circuit? Nothing coming in yet.
Okay, we are going to give them a few more seconds to see.
So I'm sure they're typing very, very busy.
Yeah.
And here comes the first one. It is a complete circuit, so flow goes through.
Yep.
Somebody says it's something that you can turn on and off.
Okay.
One more, a full circle with no opening.
Okay. All those answers are right. So closed circuit is nothing but it connects every
I'm sorry, Sujan, I got one more that just came in. Everything is connected and it allows the electricity to flow.
Yes, exactly. That's it. That's what a closed circuit is. So it allows the current to flow from the source to the components, from the source to the load. And we are using a switch here where it essentially makes or breaks the circuit or makes it open or closed. So we are going to see how this actually works in real time. So this is the load and this is the battery and this is the switch. By opening and closing the switch, we actually can make an open and close circuit. So we are going to see how that works. So I want to know what you guys think was happening in the video. So I'm going to wait a minute to see what you guys answer to this. So what do you think is happening in the video? And what is that paper with those paper clips? What is it acting as?
All right. So the question is, we saw the video and now we want an explanation. What's going on? What's that paper with the paper clips? What's it doing? I don't want to give away an answer. So we'll let everybody type in an answer. Nothing coming in yet. Like I said, I'm sure they're frantically typing right now.
Yeah.
All right. So somebody says it's making a long battery. The magnets are creating a magnetic electrical connection. Since metal is a good conductor, when they both touch, the current can flow. Those are the three I've got so far. Did I miss one? No. That's what I got so far.
Okay, we are just going to give them some more time just to see what they're going to answer.
All right, the next answer says that it's making a battery. And we got one more. The paperclip helps it make a connection.
Okay, so I'm going to explain what's happening. So in the video that you have seen, you see that the bulb only lights up when the paper clips touch each other. That's because it's acting as a switch. Right here, this part is acting as a switch. So when the paper clips touch each other, that it allows the flow of electrons and the circuit is complete. So if you look here, you see that the okay, sorry, just give me a second, guys. So yeah, so the paper clip and the paper is acting as a switch, And as you can see, the bulb only lights up when the paper clips touch each other. That's because, as one of you guys answered it, the metal clips, because they are made up of metal paper clips, they conduct electricity and the paper doesn't. So that's why only when they touch each other does the lamp light up, otherwise it doesn't. So this is essentially acting as a switch. So it can either be a closed loop or an open loop. So hopefully that answers your question. So we are going to do a poll this time to see what you guys think of this. So what items are needed to complete a simple circuit? I don't see the poll, but Stephanie, I don't see the poll. Okay, yeah, I see it now. So
it's been there the whole time. I mean, I saw it. No, I'm kidding.
Okay. So I have 3 questions. I hope all of you answer it. Even though you're right or wrong, just let us know what you think. So what items do you think are needed to complete a simple circuit? And do you think open circuit allows the charges to flow? And are metals like copper, aluminium are good conductors of electricity? Is that true or false?
Yeah, these answers are coming in now. We've got 10 of them so far. I think last time we had 17 again. 13 so far. So more than 50% of you have answered. And just like Sujana said, if you don't know, take a chance, take a risk. Give us your best answer, because that's what our hypothesis is. It's what our best guess is. We got 14, 15. See if we get a few more. All right. 16.
Yay.
Can we get one more? We just got a comment from one of our students that says, man, these people are good. To the person that said that, you're pretty good too.
Yep.
All right, Sujana, we're stuck at 16. So
okay, so I see a lot of correct answers, which is good. So you guys are good. So the first one is, what items are needed to complete a simple circuit? Is you usually need a source, which is the battery, and you need wires because they provide the path for the electrons to move, and a load or a light bulb for it to glow or to show us if the electricity is passing through or not. And open circuit allows charges to flow? No, it doesn't, because it's an open circuit. It's not a closed loop, so there is no way for the charges to go. And most of you got that right. And metals are good conductors of electricity. That's true, and that's 100%. All of you got it right, so yay. So I think we are done with the poll, and let us know if you guys have any questions so on anything we have discussed so far. So I'm going to give a few minutes for them to see if they have any questions. If not, I'm going to hand over to Stephanie.
Yeah, I think we can go ahead and turn it over, and everyone continue to type in your questions. Yes. I can see them, and I've been given permission to interrupt to ask questions, right, Yulia? Yulia's talking.
You're
she's muted.
There you go. Hey, thanks, Carlos. Yes, that's what we have Carlos for. Type your questions in there for Sujana, and Carlos will pop up and let us know. Stephanie, if you're there, we'll pass it to you for our library picks. Stephanie, it's all yours.
All right. Can everyone see me? For some reason, I'm not.
Yes.
There we go. Okay. Well, thank you all for coming. Thank you for our MagLab scientists. That was super fun and exciting and just very educational. I really enjoyed it. I just wanted to share with everyone, if you're interested in learning a little bit more about electricity and what we talked about tonight, we have a book list here that I have put together, and our graphics team put it into a nice little format for everyone. If you click on that link, it'll take you to it. Each of those book recommendations, if you click on the title, it takes you to where that book is in our catalog, and you can go ahead and put it on hold, and the library will grab it for you, and you can come and pick it up. So I just wanted to share that with you. And if you are interested, we have some more programs coming up at the library. I'm going to steal the screen share. I hope that's okay. Just briefly. So we have a bedtime maths Crazy Eights Club coming up on October 2nd, and it's every Saturday. And so it's learning about math, which is like a close cousin of science. Scientists can correct me on that, but
Totally right.
And October 2nd, we're doing a glow in the dark geometry. So you're going to make geometric shapes using glow sticks. And that's at the East Side Branch Library. We have the tween scene, which is for grades 4 to 6. That's coming up. It's the first Thursday of each month. And there's a fall fun theme for October 7th. And then I just want to remind everyone, if anyone needs homework help, we do offer weekly virtual and in-person tutoring at the library. So if you want to get set up with a tutor, just go to our website and you can fill that out if anyone's interested. And that's the end of it for my part. I'll hand it back over to you, Leon.
I'll take it if that's okay.
Or yeah, go ahead, Carlos.
We had some questions that came in, and these are all the important questions. Sujana, first of all, somebody wanted to ask, how was your day?
It was good. It was good. It's Thursday, so yeah.
And Sujana came. Yeah, she came by my office earlier, and we were talking, and I reminded her that it is Friday Eve.
Yeah. Yeah. The new Friday.
That's right. It's the new Friday. The next question was, what were the scissors for in the presentation?
Oh yeah, so I had the scissors down there so that this is the plastic bag, and I wanted to do like a band so that we could actually see it levitate with the balloon. So that's what the scissors are for. So if you didn't have that, that's fine too. I just included it so if someone needed it, could have it.
I have an excellent question. Are you ready for this one? We got some physics now. Why did the sticks get warm when you were rubbing them?
So that's because of friction. So if you rub your hands too, you could see them, they are warm. If you touch them, they become warm, and that's because of friction. So I guess that's your answer. I guess if Julia wants to add something to that.
Oh, well done.
Okay.
There's a question that I can take asking about the middle school MagLab mentorship. And it pains me to say that unfortunately this year's middle school mentorship was canceled. We are unable to host students at the lab, and we really want them to have the lab experience. So we will start middle school mentorship up again next summer. The applications will come up at the end of the school year. Let's see, somebody want to go on camera. I'm sorry, we can't have you on camera. It's because we love ourselves so much. We like seeing ourselves on camera all the time. Oh, and the link for the math night. Stephanie, can you share the link for the math night there it is.
I just sent that now. Actually, let me share it with everyone. And that's an in-person event, so there's no like Zoom link, but I can give you the link to the calendar event if you want to learn a little bit more about it.
And of course, am I too old to play with glow sticks and geometry? Because I want to do that. That sounds like a lot of fun.
Absolutely not. Grow old, but never grow up.
Okay, Julia.
All right, Sujana, if you want to throw the slides up back for us, we want to show you when we meet again. If you choose to join us again in October, it was a lot of fun today. So thank you, Ms. Sujana, for preparing all of this information for us. In October, we are having Dr. Faith Scott, another MagLab scientist, join us. And she's talking about genetics, DNA, forensics, the science behind CSI. So come and play with us, learn with us, explore with us. We are meeting again in Zoom land. So there's a link on the website, on the MagLab website, as well as the library website. We're meeting on October 21st. At 6:30. Until then, we have lots of our science nights recorded that you can watch again on our MagLab YouTube channel. Also, the video of tonight's event will go there. And follow us on social and post to social, hashtag Science Night, hashtag National Mag Lab. And if you want to email us and send pictures of yourself experimenting, sciencenight@magnet.fsu.edu. We're always excited to hear from you guys. Thank you so much for joining us tonight. We appreciate you all. Thank you again, Sujana. Thank you, Ms. Stephanie, for hosting us. Thank you to our awesome chat master, Carlos. And with this, I pass to Carlos for our very final closing remarks.
I love that I get to wrap up the whole show. Somebody just asked, will we have any more? Yes, third Thursday of every month. You can join us. We do skip December. But other than that, we'll be here the third Thursday. You can always go to the website, the MagLab website, and get more information. So last thing I want to tell everyone is that the National Magnet Lab is taxpayer funded by the National Science Foundation and the state of Florida, making all of you stakeholders in our facility. So on behalf of all of us, thank you for supporting our science. And of course, the last thing I need to say, which is the most important thing I need to say, stay nerdy, stay geeky, and stay true to who you are. Science is an activity for everyone. So be nice to those people around you. So for Sujana and Stephanie, Yulia, from myself and from Groot, everyone have a good night and we'll see you next month.
See you. Bye-bye. Thank
Bye-bye.
you.
Thank you.
Bye, everyone.
Thanks, everybody. Bye.